with James and Dennis. Let's welcome them. Okay, you're good to go.
Thank you very much, Diego, for that introduction, and Martin and the rest of the team. We're a bit of a late entry, so thank you very much for making the time. So there's 4 parts to our talk today. Dennis is going to set out in a moment the vision behind the DamaHub library, and then we're going to go into a fully live demo, so hope the gods are with us, covering a lot of ground, and then the use case. So we're sort of learning by doing, so we want to share that, and we've got lots of problems, and we've heard lots of answers over the last day and a half, so more feedback would be greatly appreciated. So I met Dennis through the Blockchain for Science community about over 5 years ago. So Dennis, tell them the story that inspired me and others to get involved in DamaHub.
Hi guys, thank you for having us, and thank you for introduction, James. Our journey in data, my journey in open data started in about 2010 when I came into realization that when it comes to access to data, governments and corporations have all data almost real time and in machine readable formats, which is generated continuously by us, whether we're carrying personal tracking devices known as mobile phones or using our credit cards. But when it comes to citizens' access to information which is generated on their behalf and taxpayers' expense, data was, if it was available, it was either outdated, it cannot be trusted, or it was in non-machine readable and proprietary formats. So we started to think here in Ireland what we can do about it, and more of us wanted to bring as many minds into the space and started to organize regular meetups and hackathons with an idea to bring on the regular basis into the same physical space people who had data, public servants, for example, people who knew what can be done with this data, like developers and software engineers, and people who knew how to put this data in context, like academics or journalists, which worked well, and we created some traction on policy level. And in 2014 at Open Knowledge Conference, Open Knowledge Festival in Berlin, I met a guy who told me, Max Ogden, his name, who told me about that. So it's going to be 6 years since I've had first time about that. So by 2015, more and more data sets became available for use here in Ireland, and what hit us is the question how we can trust this data will be available tomorrow, and how can we trust this data in general. So we started to think how to employ peer-to-peer technologies to preserve public data, valuable data in machine readable authenticated formats. And we realized about that the same time that there is the similar problem with preservation of scientific data. So we started to think and to engage more with university librarians and with academics, organized a couple of gatherings in Berlin and in London. In 2018, we engaged with British Library, and we had today event over there as well, just thinking collectively about how make data which is generated through publicly funded research available to anybody in useful formats. And while we wanted to see, I see data as a part of critical public infrastructure. In the same way, we think, like, for example, each data set can be seen as a cobblestone in a road. And roads are designed and built to last at least decades, and if they maintain properly, the last centuries or even millenniums. Yeah, each data set is a cobblestone, which is a part of this infrastructure. But at the same time, applications which we are building to explore those road networks can be seen as vehicles, and we change vehicles, whether it's cars, buses, or bicycles, every 20 years, and roads remain the same. Yeah, so like what we need and what we thought is needed is a network which enable, like in the same as a road network, enable people to travel from A to B. People should explore data which generated by public bodies or academics in the same way, and that network needs to be reliable, and it needs to be properly maintained. So that's what we've been thinking on the background, and now we can go, I believe, into the live demonstration on what we've been working on. Over to you, James.
Thank you, Dennis. Dennis has this slide where he puts up 4 roads in varying levels of condition and how they were built. And I think this road metaphor is powerful, and it sort of builds on the data landscape that we heard in some earlier talks. So I'm going to go through a demo, and the demo is kind of full scale. And we're just going to try and focus on the library part of it. But the use case is we're liberating data from wearables using a project called, open source project called Gadget Bridge. And we want to follow that data from its origin all the way through to me to do some personal data science on it. And the library is the vehicle we use to make data interoperability across different data sources. So I'm just going to flip to the demo. So I'll get no prizes for UI, but so this is running against live a hypercore hypertree, and just using a WebSocket, and we'll come on to that. So Dennis has been all around the world talking to these librarians. I've not had the energy, but so we go to a lot of data conferences like RDA, so describing the data at a very fundamental level. And so there's things like research objects. And so we just thought, right, let's take that use case. It's the use case that comes up in our discussion with librarians. So how would that work? So we have get the data types. So I've already made the data types to describe this Gadget Bridge data store. So let's say you wanted to build a new data type, then you click on a new, you select the data type. Is it primary? Yes. In temperature, and you can put in your own description. And just to save me some typing, then there's already existing semantic knowledge on what temperature is. So we put it in, and of course, every Wikipedia page will have a Digpedia page. So this is like building on the knowledge. It's already out there. And the measurement units is Celsius. And the structure is float. So I then save this. And if I then go back to my, and if the demo gods are with me or not, yeah, temperature. So we now have our temperature. So again, no formatting, really had time to do this, but you can see how we've got the description, but then you got your key address. And obviously you can have version 1, version 2, the date. And I'm going to talk later on about how we bring democracy in terms of the consensus around whether this is the best way to describe temperature. So we have data types, but data types don't exist on their own. Then we'd actually need to do packaging. So it's great to have the talk by Mauve just beforehand, because the library is data source agnostic, and that means the peer-to-peer web and the cloud. So I usually have my Firefox browser with the IPFS plugin, but that wasn't working today with BBB. So so today we're just going to do a REST API. And so again, you click on create a new reference contract. This time it's packaging. And I'll say Gadget Bridge, type of data store. So yeah, so REST. In your I'm just making this up, and I'm going to save it, and then compute data. And then you have to add the columns. So here's a bit of like risk. So when I actually upload, let's say the REST API, it could give me the template. You know, so then I wouldn't have to type in, because if I type in timestamp and I do a typo, so anyway, I'll manually add it for now. So it creates a column, and then I've got my temperature. Let's say the column is just called temp, so I just add it. And then all the data types are in the library that have been agreed are now available to me. So I just drag in the timestamp and the temperature. And then life is not quite as straightforward as that in most cases. You know, in the wearables use case, there's like columns that give you codes that mean whether you're sleeping or you're active or you're running. So that's what this category is. And also there's things like if the wearable's being charged up, it will give you a number in the heart rate column. So you wouldn't use a heart rate of 255. So anyway, you fill in these forms, you save it. And then again, if we go back to our, we have our packaging contracts. So again, the hash of the of this packaging contract, and then all the components of it, and you'll see how I put in the proper REST endpoint and its part, and then this mapping between the data types. So for example, Fitbit could describe their REST API on this and would use the same time stamping code, but would maybe they've just called it time for their column. And then this bit below it, it's this categorization, and that's to do with sleep and you know, the data. Right. So we also have to do that, and we won't do it today, for compute contracts, unit contracts, modules, and then the visualizations. So this is a contract that describes the use of the Charts.js library. Right, phase one. So the library's there, and I now want to use that in a citizen science experiment to actually flow the data. So the first stage in that is to create an experiment. So I've been building this tool. So I want to create a new network experiment, and it's to do with movement and heart rate. And then I drag in these modules, the first one being data source. And then it asks me to use the network library. And in the real world, I would just be typing in heart rate Gadget Bridge and it would come up, but we don't have that level of UI in yet. So I have to actually just use the key for the packaging. So again, I get instantly the same information because it's connected to the library. I am going to use a compute contract, and the compute contract is just a straightforward observation. So it's not doing any like statistics on it. So again, I can just put that key in and it will bring, and now the last stage is to say, okay, I've got to visualize it. And so again, I bring in the contract. And now we have the tools surrounding it. And then I can just say, yep, I'm going to plot the time on the x-axis. Again, this is all integrated because the library is compatible, and heart rate. I'm going to do some sleep analysis on it, and I want a daily, and the resolution is per minute. And I click learn, and then I would have my chart. And that's not active on this version of the product. But just to show you what's possible once you've got these contracts, then you can create these what are called lifestyle dashboards. So I'm a swimmer, and we've got heart rate data. So I select the heart, and then I click. So I get my swimming times through a stopwatch app, and then here I have my wearable data, which is coming through the experiment. And of course, it's not just heart rates and personal data, it's also environmental data. So I've been working on the Luftim Datum project. So again, you have these air particulates coming through. Right, that seemed to work. So two big ideas to leave you with, and one of them came from the Blockchain for Science community. And I'm going to use an example that when we're creating a data type called water, H2O, then it actually has a molecule structure, and then it has the movement of the fluid. And so this person gave a talk saying how you could actually use cryptography to actually capture the information. So the contrast is to make that the most popular referencing of chemistry data is a thing called CAS numbers, but they're just like the sequence number of the database that the American Chemicals Association used. Whereas if you go to Wikipedia, you'll see a project called Inchi, and Inchi actually used cryptographic hashes on the molecule bonds to describe the identifier for the molecule. So you're actually guaranteeing that you're getting, H2O. It turns out that when you get polymers and more complicated chemistry, then you get clashes between the cryptography. But this is the big goal, that these data contracts are trying to capture in cryptography the hashes of the actual meaning, whether it's the semantics or the physical space or its computational model. And then the second thing was this call out, which was help. So right now I've not, we've done little experiments about using, kappa and multi-core, but then the question comes up, is the data type contract should be its own hypercore hypertree? Should it be the consensus come around the experiment, so everybody's doing wearables, agrees on the data types, and then feeds in their sources. So just to simplify, we have these web forms. We call through a composer. Think of a composer in blockchain speak as being the smart contract verification, and we want to bring in some governance over that process so that when you publish the reference contract, the community sort of agreed. And as I said, whether that's globally per experiment or per your own experiment. Dennis, what's our next stage of our use case?
Well, look, we live in a global world, and this conference is global. Maifo speaking from Canada. I was born in Soviet Union. Now I live for the last 20 years in Dublin, in Ireland. James is somewhere in Highlands, Scotland. There are 7 billion of us, and we're all different, but at the same time, we have the same thing in common. None of us have ever decided when, where, and by whom we were going to be conceived. So we didn't choose our skin color, our gender, or our DNA, for example. We all want to live our lives in a happy and healthy manner. And this depends on the quality of air which we breathe. We know now with this, just stepping back a bit, the problems which we are facing are global also, whether it's global warming or, for example, the viruses which are going around. And viruses, like algorithms, they have no borders. So to deal with those viruses, we need a strong immune system. And to build this immune system, we need to breathe fresh air, to eat nutritious foods, and we need to exercise regularly. So we believe that helping everybody anywhere in the world to make informed choices about the lives they are living, about how clear air they breathe and how nutritious their food and how regular they exercise, and to be able to combine all this information and to process it and to make informed decision based on it. will enable people to live happy and healthy lives. But like to do it, we need peer-to-peer network of libraries which will preserve data which is generated on citizens' behalf in authenticated and findable, accessible, interoperable, and machine-readable formats.
Yeah, so thanks, Dennis. So we basically have this attitude learned by doing. So we also are climate activists, and my local library is cutting back its services. And so we do think that the library and these relationship libraries can be at the heart of our communities like they were for books, but introducing the data science element. And so we're going to try and take this public open source Lufton Data community, which is cloud-based, with this wearable, more private, secure. And I know the next speaker is doing agriculture, and we were already speaking to one group about open soil testing. And it's those communities coming together that really gives us the evidence to make informed choices. So with that, we'll look at questions, and thank you very much.
Can you move to the next slide, please? Yeah.
Dennis, can you see the questions? I'm sort of gonna look them up on my phone.
I don't actually. Sorry for the response chat. So guys, where can I see questions?
I saw there is one question, I guess, from Jeremy about, so this is more like a preservation tool or more like a knowledge graph tool for librarianship?
I could just ask you directly, probably clearer. So like, as far as I understood the purpose of the contract, it's kind of like you have something like Open Refine acting on like a DWeb contract basis. So like you have your own data that you've gotten somehow, and you're doing a reconciliation process where you're mapping that to like an entity graph, and then you're producing like a building block style query structure against that. Is that correct?
Yes, the network library is basically saying if Fitbit and the Open Humans Protocol and Tencent and the new one that we're focused on is Bangle.js, open hardware, open data. But they've all chosen to describe the data coming off the sensors in different ways. Whereas peers, me and Dennis just want to do, share our air quality and health data science, and we use different measurements and different inputs, but we want to compare them. But the library's job is just to make that possible. Then you could build, I've used the DIY toolkit. You could use Juniper notebooks. You could use any library you wanted. But
okay, so the library's job is not to pull down others' data repositories or anything like that.
No.
Okay. Got it.
As there is a suggestion that would be useful for remote clinical trials. It's possible.
So just a bit of background. So I started my peer-to-peer journey, I think it was back in 2003, creating a peer-to-peer text search engine for WordPress. And that morphed into, in about 2010, I met the founder of Fitbit when he was 2 people. And obviously we've seen through the Web 2, this data silo machine that still exists today. So what I did was I open sourced using Arduinos and Raspberry Pis, a timing system you might see like at the Olympics for swimmers, because I'm a swimmer. And so basically that was the genesis of like the toolkit, was to create a clinical trial for swimmers, or a sports science trial, where, you know, the coach says kick your legs more, and another coach says not, and then they race and one's faster. So that's the kind of use case that was at the genesis of the toolkit. But if you push that forward into like medical clinical trials, which we've spoken to academia and, you know, people that run the trials, it's a whole different ball game of rules and regulation, and we sort of backed away from that at the moment. And plus, you know, they were skeptical of all this peer-to-peer crypto stuff. But yeah, I think it's a use case that's coming down the line.
Excellent.
Yeah.
Sorry. Well, yeah, I guess that we're on time, and I want to say thanks. It was a great presentation for you both. Thank you very much, Dennis and James.
Thank you.
Bye.
Good. Well, next is coming. I guess that we will have Don, and he will tell us a little bit about using that and hyperstack in agroecology. This will happen in a couple of minutes. Stay tuned.